Okay, guys, this is paper 2 from last year's externals. Again, I have copied in the solutions that QCAA have provided. The formatting, unfortunately, doesn't work very well some of the time, but again, as long as I explain it, I'm sure that'll be okay. Okay, so question 1 is basically asking if the reaction between zinc and copper sulfate is a redox reaction. The zinc obviously is turning into zinc ions, the copper ions are turning into copper, so therefore it is redox. Zinc, of course, has been oxidized and copper 2 plus has been reduced. This is a simple metal displacement reaction where a more reactive metal is displacing a less reactive one. Again, you have your chart of the electropotentials if you need to use it, but I'm hoping that that's pretty straightforward. Okay, now then, this is not quite so straightforward. Determine the reduction half equation for this reaction. What you've got to do effectively is recognize what is being reduced. And if you check the oxidation numbers, nitrogen here is +5. It doesn't change there, but it's becoming +4 there. So it's the nitrate ion there. The H plus is +1 on both sides. So if you take out the nitrate ion, you're going to need the H plus ions in order for balancing to take place. If you can remember doing equations like manganate and dichromate, you're not going to have enough oxygens, obviously, to balance NO3 with NO2. So you add H2O to include extra oxygen, which means then H plus has to be put on the left-hand side to counteract the hydrogens in water. Balance the atoms first. That's a negative charge. I know the formatting doesn't make it look good. That should be a 3 minus there. NO subscript 3 and superscript minus. Okay, so it doesn't look good on the formatting, but I'm sure we're okay on that. Once you balance the atoms, then you balance the charges by including electrons there. To work out the standard reduction potential for the reduction half equation, now copper is going to copper 2 plus, and effectively that means it's going backwards here, which then makes that minus 0.34. So if the overall voltage is plus 0.46, then effectively the reduction potential for this equation has to be plus 0.8. So when you subtract 0.34 from it, you're going to get 0.46. Not quite sure if that is easy to follow there, but hopefully it makes sense the way I said it. Okay, and then it says, why does copper dissolve in concentrated nitric acid, but not in concentrated hydrochloric acid? Well, again, hydrochloric acid would involve the H plus ion becoming hydrogen. That's got a value of 0. The value that we just worked out was plus 0.8, which is a much more likely reaction. So effectively, when you are doing the maths, if you like, you know that a positive sign means it's likely. So clearly, the hydrogen one, of course, this one going forwards and this one going backwards would be a negative sign. So therefore, there's no way copper is going to react with hydrochloric acid. But the nitrate ion is plus 0.8. That would put it down here. So nitrate giving NO2 would be plus 0.8, the same as this reaction here. And plus 0.8 minus 0.34 gives you a positive EMF, and therefore it will dissolve in concentrated nitric acid. NO2 is the product rather than hydrogen. Same reasoning. Hydrogen obviously is 0. NO2 was plus 0.8. It's more likely, and therefore NO2 is the product. Okay, so it's all about positive versus negative. Positive is likely, negative is unlikely. The more positive, the more likely. The more negative, the more unlikely. Use the chart, and you shouldn't have too many problems there. Okay, so we have a reaction to produce aspirin from salicylic acid. You've probably never heard of that stuff before. It doesn't matter. It's not going to be tested. It's just they're giving you the equation for the manufacture of aspirin. And as you can see, it's reversible. H plus ions required for the forward reaction. Identify the type of reaction this is producing. Now we are turning an alcohol, hydroxyl functional group, into an ester. And therefore, this is a condensation reaction, which is what the syllabus requires you to know. However, the answer they have put is esterification. That's not specifically mentioned in the syllabus. However, if you can remember your biodiesel, that is produced by a trans-esterification, which basically turns one ester into another. So maybe the word esterification would be known from that. The Casey expression using the simplified molecular formulas, this concentration times that concentration over that concentration times that concentration. Determine whether the concentration of reactants or products is greater. If the Kc is small, certainly less than 1, then effectively the reactants must be greater than the products. So, and that's all they're asking. All right, so the concentration of reactants would be greater if K is less than 1. Calculate the mass of salicylic acid required to produce that many milligrams of aspirin. Okay, so we turn that into grams. We divide by the molar mass of aspirin, and that's going to give you the number of moles of aspirin, 2.78 times 10 to the minus 3. There's a 1-to-1 ratio in the equation. If it was 100% yield, then obviously this would be the number of moles of salicylic acid required. However, it's not 100%. The yield is only 45%. Therefore, you have to divide that number of moles by 0.45. Now, if you're thinking, why divide it? Okay, it's a maths thing. Let's say it was a 50% yield. Then can you see you would need twice as many moles of reactant if it was only going to produce half the yield? What that means is you'd then be dividing by 0.5. So effectively, you're dividing by whatever that percentage is, but turn it into a decimal. Don't divide by 45. If you do divide by 45, remember to multiply by 100. It's a percentage. So the moles of salicylic acid will be that, and then multiply that by the molar mass of salicylic acid, which is 138, and you're going to get your mass. This is in grams, convert it to milligrams, and there is your answer. When the reaction is heated, the concentration of the product is increasing. Apply Le Chatelier to predict if it's exothermic or endothermic. If you heat, then Le Chatelier says, then the system will oppose you. Therefore, it's going to move in the endothermic direction, which clearly means the forward reaction here is endothermic. Production of ethanol by fermentation of glucose. There's the balanced equation. Make sure you know these formulas, guys. And a catalyst is required. The catalyst is yeast. To be absolutely sort of correct, you'd have to say the enzymes in yeast, but you can see this is QCAA's answer. They're quite happy with just yeast. Calculate the atom economy for the reaction. Now, atom economy is the mass of the desired product, which of course is ethanol, divided by the total mass of all products, multiplied by 100. So ethanol is, let's have a look. Oh, they have not balanced this equation correctly for you guys. There should be a 2 there in front of the ethanol. And therefore, 2 times the molar mass of ethanol, divide by the total masses of everything, which is, of course, the same as the mass of that, 180.18 times 100 gives you the atom economy. In terms of atom economy, which process would be the greener, the hydration of ethene or the fermentation of glucose? When you hydrate ethene, you're going to get only ethanol as the product. Therefore, the atom economy will be 100%. So clearly, from an atom economy point of view, the hydration of ethene is greener. I would argue that since ethene comes from crude oil, that may go against that green thing. Fermentation, of course, uses sugar, which is renewable. Two principles of green chemistry other than atom economy that make the production of so now they're talking about production of ethanol and the fact that you can use sugar, which of course you can keep growing, and it's also more energetically efficient because you haven't got to use high pressures and high temperatures and catalysts. It'll work at about 40 degrees centigrade and at room atmospheric pressure. You could also argue the fact that ethene comes from crude oil. That would be a third answer you could use there. Okay, identify the molecule as saturated or unsaturated. The double bond, of course, makes it unsaturated. It's methyl propene or 2-methyl propene, either would be accepted. An equation to show the products of the hydration. Now, when you add water to this molecule, there are two possible ways it can go on. The hydrogen and the OH will split. The hydrogen may go there, the OH there, or vice versa. So these are your two products. I'm not very keen on the brackets, so you may want to draw those out properly. So effectively, CH3, CH, CH3, CH2OH, or you can put the OH there and then make that a CH3. Okay. Now, in one case, you're going to have the OH there. That's going to give you a primary alcohol. And then in the other, you're going to get the OH on that carbon, which would be a tertiary alcohol. The next question will ask you which is the major product. The major product would be the tertiary, because Markovnikov's rule tells us that the hydrogen will go to the carbon that already has more hydrogens. Identify a physical property and experimental technique to separate these products by hydration. Now, this should not have been asked. This is unit 1 or 2 work, which of course is effectively how we get products from crude oil. Fraction distillation is used because different boiling points will be separated by that technique. That really speaking, they would argue they can ask anything they like from units 1 and 2. Personally, I think that's a bit unfair. I think this question should have read, how could you identify which was which in terms of which alcohol is which? The primary alcohol can be oxidized, the tertiary cannot. Dichromate would go from orange to green. Manganate would go from purple to pale, pale pink. This one would not change the color at all. Okay. Again, intermolecular forces they talked about are stronger for the primary, and I would go along the lines of the straight chain would be better from a dispersion force point of view. Here they've got talking about hydrogen bonds and exposure of the OH. I'm sorry, they should not be giving you stuff like that. That is totally outside the syllabus. Go with the dispersion forces, guys, I would. Okay. Okay, name compound A. This is an amine, ethanamine, easy enough. The Bronsted-Lowry acids. On the left-hand side, water is donating the proton. On the reverse reaction, this compound here, this ion here, sorry, would be donating the proton. So there are your two Bronsted-Lowry acids. If you add hydrochloric acid to the mixture, it'll remove the hydroxide ions and become water. By Le Chatelier, the system will shift in the forward direction to replace the hydroxide ions, and effectively the concentration of A would decrease. Calculate the pH, a 2-molar solution. This is a weak base. So you do your 2 minus X and your X and X. Okay, so your 2 minus X, X and X. Your Kb would equal x squared over 2 minus x. 2 minus x can be simplified to 2 because it's a weak